Hey guys, Chavez here. We're getting ready to do another exciting YouTube video, and today's topic is gonna be motion. We're gonna look over it again, guys, because that's a topic that we didn't do very good on mock exam number one. So I hope you're safe at home, and I hope you're enjoying. I hope you're enjoying whatever it is you're doing. Maybe you're doing some cool math, because obviously you're looking at my video. I got my coffee, and yeah, let's have some fun, guys. So let's get to it, and let's take care of this math life, guys. So yeah, let's do it. All right, guys, here we go. And what I mean by weakness, guys, we didn't do as hot as we could have on the mock exam number one, but we're going to turn that weakness into a strength. So let's get right into it, guys. So this one's from the 2004 AP exam. It's calculator active, so that means we're going to need a calculator, and I have a calculator emulator right here. So I'm going to use it in a little bit, and I'll show you what we're going to be typing in. So it starts with a particle moves along the y-axis. So understand that you're either moving up or down. So there's velocity v at a time t greater than or equal to 0 is given by, and this expression tells you your velocity. At time t equals 0, the particle is at this position, -1. You're either moving up or down, guys. So you're at some position, -1, at time equals 0. It says, find the acceleration of the particle at time t equals 2. This is a straightforward question, guys. To find the acceleration of a particle, we take the derivative of velocity. So we just got to show that. So here's the setup. I'm going to say acceleration at 2 is equal to the derivative of velocity at 2. And that equals, well, I'm going to take the derivative of this guy, and I'm probably going to be using this guy over and over again, guys. So what I would recommend is for you to type this into your Y1 of your calculator. So here's my calculator, and I'm going to type that into Y1. Let me see if I can move this over here and that on the left-hand side. And for now, all right, so there we go. So I'm going to go to Y equals, and I'm going to type that equation in there. 1 minus arctan. Make sure that your mode is in radian mode, and minus 1 minus arctan, second arctan, and then it says e to the x, second e to the x. And there it is. I have it in Y1, and I want the derivative at 2, so I'm going to go to my home screen, and I'm just going to go math, and I'm going to look for derivative, and I believe that might be number 9. So some of you guys are probably saying, just push number 9, Chavez. Okay. Sorry, my laptop here has a little delay. Yeah, it's number 9. It's number 8. So there it is. I'm going to put x in there. I'm going to put alpha trace y1. And I'm going to put at x equals 2. I'm going to push enter. And there's my answer, guys. So negative 0.13290. They didn't give me units. So you're fine right there, like so. You can always put more than 3 digits after the decimal, your thousandths place, but you can never put less. If you wanted to type out the whole thing, you could, but we're going to be using this one over and over again, so that's why I decided to do that, guys. All right. Is the speed of the particle increasing or decreasing at t equals 2? Give a reason for your answer. All right, to figure out if this particle is increasing in speed or decreasing in speed, we're going to have to figure out what the acceleration is. Because we need two things. We need to know the velocity and we need to know the acceleration. If the velocity and the acceleration have the same sign, then the particle is increasing in speed. If the velocity and acceleration have opposite signs, then the particle is decreasing at speed. It's slowing down. So let's find that out, guys. So I'm going to write, I know what A of 2 is. A of 2 is simply negative 0.13290. I'm going to figure out what V of 2 is. So again, I come to my calculator and I already have it in Y1. So I'm just going to go alpha trace Y1. I'm going to put 2, open parenthesis, 2, close. So this is going to give me my velocity at 2. And it's a negative, what is it? Negative 0.43627. Negative 0.43627. Because acceleration and velocity have the same sign, the speed of this particle is increasing. Since acceleration, I'm just going to put, since A of 2 and V of 2 have the same sign, comma, particle is increasing particle speed is increasing. At t equals 2. And I think that's full credit right there, guys. And then it says, find the time at which a particle reaches its highest point. So remember, you're moving up or down. So I'm going to look at this graph here. So I have my y equals, this is my velocity equation here. And I'm going to look at it from 0. Did they give me a constraint? They did not. So let's see how this graph looks from 0 to 10. And I guess for now, let's leave negative 10 to 10. And let's see what we get when we push graph. And I can already see something's going on. So I'm going to zoom in, because obviously you can't really tell what's happening between 0 and 2. So I'm going to really zoom in there, guys. So I'm going to go, let's see, y min, negative 0.5. And then y max, I'm going to go 0.2. And I'll push graph. And now I can really see what's happening. All right. So I want to see a little more of that behavior. So I'm going to go y min to negative 1. There we go. That's better. Now this graph is going to stay below the x-axis for all values greater than this value here. And because that's how the behavior is, right? You have 1 minus arctan. So remember how arctan looks like. So 1 minus arctan. This is always, so what we got to do, we need to find the intersection right there, guys. So how do we find that? Well, that's called a 0. So I'm going to go second, calculate, and I'm going to put 0. And then it's going to say left bound. What do you want me to search? So I want you to search between, and you can probably type in 0 if you want. But I'm going to go ahead and just move the cursor there. So I want you to search between there, left bound, and right bound. I want you to search between those two values there. Push enter. And it's going to tell you. So because, remember, this is velocity. If I'm above the x-axis, the particle is moving up. And then after this value, 0.443, you're moving down forever and ever and ever and ever and ever after that time value. So they want to know for which value the particle reaches its highest point, justify your answer. So I'm going to write, what value was that? 0.443. 0.443. So I'm going to write, I'm going to put over here t equals 0.443. I'm going to put particle reaches highest point at t equals 0.443, since this is the only time particle switches velocity from positive to negative, comma, meaning reaches highest points, meaning reaches highest point at t equals 0.443. So I want you guys to think about what we just said. It reaches its highest point because my velocity just switched from positive to negative. If the velocity is positive, you're moving up. If the velocity is negative, you're moving down. So I want you guys to get that through your head, guys. Okay, so now next it says find the position of the particle at t equals 2. Is the particle moving towards the origin or away from the origin at t equals 2? All right, well, we need to know where we are first before we can answer the second question. So let's do this. So position of the particle, so it's y, because remember, we're moving up or down. Position of the particle as y equals 2 is equal to my initial position at 0, which they gave me. My initial position at 0 is negative 1. See? So my initial position at 0 plus the displacement of this particle between 0 and 2. Now, how do I find displacement in calculus? Well, you take the integral of your velocity. So, here we go. Y of 2 is equal to my position at y at 0, which if I remember was negative 1. I hope my memory is not that bad. All right. Plus integral from 0 to 2 of your velocity, v of t dt. And that will give you your answer. So I'm going to type this into my calculator. I already have it in y1. So I'm going to go to my home screen so I can quit. So I'm going to go negative 1 plus math 9, that's my integral there, 0 to 2 of alpha trace y1, and then I put the x right here and I push enter. And there it is, guys. Oh, negative 1.3606. Negative 1.3606. Okay, so you're to the left of the origin. This is to the left. The origin is at 0, remember? So the origin is at y equals 0. So you're left of origin. And your velocity, I don't know if you remember, but your velocity at 2 was negative. So I'm going to put velocity, I'm just going to put velocity less than 0. That means negative. So if your velocity is negative, that means you're moving down. And I'm sorry, guys, I wrote here left of origin. You're to the bottom of origin or below origin because we're moving up or down, not left or right. So velocity is negative. You're moving down. So you are moving away from the origin. So I'm going to write that down. So I'm going to write since y of 2 is negative, and since v of 2 is also negative, comma, particle is moving away from the origin at t equals 2 seconds. Awesome. All right, guys. I hope that made sense to you guys. I think, can we handle some more? Yeah, we can handle some more. So let's keep going. My apologies for any small mistakes, guys. I usually just do one take and that's it. And if I make a mistake, I make a mistake. I want you guys to know I'm human. And I can assure you, I make tons of mistakes all the time. So if you find a mistake, put it on the comment section. If you're in my class, I'll give you 5 points. And if you're not in my class, I'll give you 5 virtual points somehow. I'll call your teacher or professor and say, hey, give this lady or man their 5 points. No, I'm not going to go that far, but who knows, maybe. Let me just drink a little bit of water here real quick, guys, and we'll continue. All right, here we go. Again, this is a calculator active question. This is from the 2005 B, so Form B exam. It can be found on College Board. And let's do this. So the particle moves along the x-axis. So now I'm talking about motion either left or right. So that its velocity v at time t between 0 and 5 is given by, and I have this velocity here. The particle is in position 8 at t equals 0. Okay, that's cool to know. Find the acceleration of the particle at t equals 4. So this is looking exactly like the last one, guys. So let me see. I'm going to move this to the left so I can type this into my calculator. And here's my calculator. So I'm going to go ahead and clear the y1. And it's looking exactly like the last one. So I'm just going to type ln, x squared minus 3x plus 3. I close this dude. So there it is. There's my velocity. They want to know the acceleration at t equals 4. So I'm going to go math. And I learned that it was number 8. So there it is, d dx. The derivative of velocity is acceleration. Alpha trace, so I can get my menu here, y1 through y0, y1, and I'm going to type in x equals 4, and I push enter, and there it is. So I'm going to connect it, guys. So we're doing a calculus exam here, so we got to make sure that we connect it with calculus. So I'm going to say acceleration at 4 is equal to v prime of 4, which is equal to, and I already forgot what that number was. Let's see here. 0.714285. That's if it's truncated. You can say 6 if it's rounded. So 714,285. 714,285. There it is. We're done. All right. Now it says find all times t on the open interval 0 to 5. So this is going to help me with my window at which the particle changes direction. Which time interval between 0 and 5 does the particle travel to the left? Okay. So real quick, guys, you're moving left when the velocity is negative. When velocity is negative. So this is not going to be enough to suffice. You're going to have to write a statement here. So let's go ahead and see and figure this out, guys. So I'm going to go ahead and look at my calculator. I already have it on y equals. There it is. And I'm going to change my window. I'm going to only look between 0 and 5. And since you just care about positive, negative, I'm going to hover around the x-axis. So I don't know exactly how this graph looks. I have an idea, but I don't 100% know how it looks. So I'm going to hover right around the x-axis there. I'm going to push graph, and there it is. You know what? I'm going to zoom in a little more. I'm going to make my y min -1. And I'm going to make my y max 3. Beautiful graph. Beautiful graph. All right. So it looks like it's 1, but I don't think it's a 1. Or it might be. I haven't factored this out. I just noticed. Is it factorable? 3, 1? No. Okay. So let's find these values here, guys. So I'm going to go second, calculate number 2, 0, and left bound, right bound. So let's do the leftmost one first. Enter, right bound, enter, go. And yeah, it's a perfect 1. So let's do the other one. Second, calculate, 0. And it's going to be, what is it going to be? A 2. Enter, enter, and it's a perfect 2. Let's see, why is that? Because ln of 1 is 0, and if you plug in a 1 in there, you get 1. 1 minus 3 is -2, plus 3 is 1. And then if you plug in a 2, 2 squared is 4, 3 times 2 is 6, that's -2 plus 3 is again 1. Oh, that's awesome. Very cool. So you didn't necessarily need a calculator, guys, here, but that's cool for us. So it changes direction. This is my velocity graph. So it changes direction at 1 and then again at 2. And you're moving left specifically between 1 and 2 because you're below the x-axis. So that's what I'm going to write. So I'm going to write, let's see, first let's talk about when it changes direction. So I'm going to write particle changes direction at t equals 1 and at t equals 2 since velocity is changing signs at t equals 1 and t equals 2. All right, now let's answer the question of when I'm traveling to the left. So I'm going to write particle is traveling to the left for 1 less than t less than 2. It could be, if you want to write closed interval, that's fine as well. You could also write an interval notation, 1, 2. Since velocity is negative, so I'm going to take out the, but it's fine with or without. Since velocity is negative during this specific time interval. And there it is, guys. I believe that's full credit right there. We've answered all the questions. Now let's go to letter C. It says find the position of the particle at t equals 2. That is, again, just like the last one. We need to know our initial position. So my position at 2, so x of 2, is nothing more than the position that they gave us. Now they gave us position at 8 at 0. So that's what I'm going to write. I'm going to select. So I'm going to write my position at 0 plus the displacement from 0 to 2 of velocity. So here we go. X of 2 is equal to 8 plus the integral from 0 to 2 of v of t dt, which was given in the stem of the statement. Up here, they wrote v of t. And I'm just going to use my calculator, and I'm going to take this guy out. So here we go. I'm going to write 8 plus math 9, 0 to 2 of alpha trace y1. And then I'll put dx, enter, and there we are, guys. 8.368 if it's truncated, or 9 if it's rounded. So hopefully I didn't make any mistakes. 8.368. 8.638. Am I dyslexic? Did I get it wrong there? 368. Yeah, I did get it wrong. 368. 368. I can't believe I did that. All right, here we go. Find the average speed of the particle over the interval 0 to 2. So remember, guys, that speed is absolute value of velocity. So speed is absolute value of velocity. And they want average speed. So average speed is, well, how do we get average velocity? It's just displacement divided by time, right? So we're going to do the same thing, but instead of taking the absolute value of velocity, all we're going to do is take the absolute value of velocity to make it the average speed. So I'm going to write average speed is equal to 1 over 2 minus 0, integral from 0 to 2. Now I need distance traveled, so distance traveled is going to be the absolute value of velocity. So that's the key, guys. That's absolute. That's the key there. So it's really simple. Absolute value of velocity is really simple to find. And then integrate from 0 to 2 and then divide by 2. Why are we dividing by 2? Because that's how much time has eluded. So distance divided by time is the average speed. So let's do that. Here we go. So I'm going to go ahead and take this guy out. Math 9, 0 to 2. And then I'm going to go right here and I'm going to type in math and then go to the number 1. And there it is, number 1. It says ABS. If there's a shortcut, let me know. I'd love to hear about it. I'm going to type in Y1 and I'm going to put X here. I'm not done yet, but I'm going to go ahead and push enter right now. And then whatever number I get, I'm going to divide that sucker by 2. So there it is. And so 0.3705. 0.3705. They didn't give me units, so there it is. That's my average speed. So yeah, we've knocked down 2, guys. Do you feel like we are ready for another one? Yeah, let's do one more. And then we'll save the last one here for either another video or maybe if we have enough energy, we'll continue. So yeah, let's do one more and then we'll save the last one for another video, maybe a short video tomorrow or later on today. All right, so it says no calculator, so from 2005. So let's go ahead and put away the calculator here. I'm going to put mine away. So there it is. I put mine away. It says a car is traveling on a straight road. So first I recognize what they gave me. They gave me velocity from 0 to 24 seconds. The car's velocity v of t meters per second is modeled by the piecewise linear function defined by the graph above. All right, that's a nice graph. It looks like a trapezoid. Find the area under the curve from 0 to 24 v of t dt using correct units. Explain the meaning of blah, blah, blah. Okay, so let's do that. So I'm going to find the area, and like I said, this is a trapezoid, so I'm going to find that. So let's see, integral 0 to 24 of v of t dt is equal to this. So I'm going to write, it's the height times base 1 plus base 2. So the difference between 16 and 4 is 12. So I'm going to write 12 plus, and then that's a 0, that's a 24. 24. And then this height here is 20. All of that divided by 2. So let's see. 2 goes into 20 10 times. 24 plus 12, 24, 34, 35, 36. 36 times 10, add another 0, so that's 360. So 360, 90 units. Meters per second times second. So meters per second times second is just meters. So this is meters. So there it is. And it says using correct units to explain the meaning. Well, this is my velocity and it's always positive. It's always above the x-axis. So because it's the velocity and it's always above the x-axis, and yes, you can say displacement, and technically you're correct. But I think a better word to use here is distance traveled. So this is the distance traveled between t equals 0 and t equals 24. Or you can say distance traveled within this 24 seconds of time. But I think it's better to state the interval, guys. So I'm going to write distance traveled from, well, I guess 360 meters that you traveled. So let me write that. It's better to write a cool statement. This car traveled 360 meters for 0 less than equal to t less than equal to 24 seconds. And there it is. I guess you could also say between t equals 0 and t equals 24, the car traveled 360 meters. This one I think is okay. I think you can write better statements. All right, let's see. For each of v prime of 4 and v prime of 20, find the value and explain why it does not exist. Indicate units of measure. Okay, v prime of 4 definitely does not exist. Let me explain why, guys. V prime of 4 from the left is equal to whatever this is. V prime of 4 from the right is equal to 0. So v prime of 4 cannot exist. So let's see if we can make sense of that. I'm going to say v prime of 4 from the left equals, let's see, so I go from 0 to 20 within 4 seconds. 20 divided by 4 is 5, equals 5. And then v prime of 4 from the right is equal to 0. So I'm going to write hence v prime of 4 does not exist. This is probably not enough. I don't think that's enough, guys. So you're probably going to have to say something like, let's see, limit as x approaches 4 from the left-hand side of, let's see, v of, okay, I wouldn't do it like that. I would do it like, let's see, yeah, you can do it like that. X approaches 4 from the left. V of x minus v of 4 divided by x minus 4 is equal to 5. And then I would go limit as x approaches 4 from the right of v of x minus v of 4 over x minus 4 is equal to 0. And in case you're wondering what is all this mumbo jumbo, guys, this is the definition of a derivative. So I'm saying that my derivative from the left is 5, my derivative from the right is 0. And so there it is. So because my limits as I approach 4 from the left and the right do not match, that means that my derivative at 4 does not exist. Hence, v prime of 4 dne. This is v prime of 4 from the left, and this one is v prime of 4 from the right. I hope that made sense, guys. All right, v prime of 20 definitely exists. V prime of 20 is smack right there. So all we're going to have to do, obviously it's a negative number. So you go down 20 units between 16 and 24. So let's see. I'm going to say v prime of 20 is equal to, and let's see, I go down 20. So negative 20 over, and the difference between 16 and 24, what's that? 4 and 4, that's 8. And then that reduces to negative 10 over 4. That reduces again negative 5 over 2. So there it is. I don't see any mistakes. Let me know if you find any. Maybe you're screaming at me behind that computer, Chavez, Chavez. So let me know, guys. I make mistakes all the time. Don't be mad. We're all human. All right. Let a of t be the car's acceleration of time t in meters per second for meters per second per second. For 0 to 21, write a piecewise defined function a of t. All right, this is going to be simple to do. Remember that the acceleration is the derivative of velocity. Well, I guess I should write v prime of t equals a of t. That's probably the best thing to do. All right, so I have linear lines. It's going to be very easy. I already found this. I already know that's 0, and I already found that. So I have everything I need, guys. So I'm just going to write a of t equals, and it has to be piecewise. So let's see, the first one we said was 5. So 5 between 0 and, okay, on this it's important, do not put the equal sign in there. Between 0 and 4. Why are we not putting the equal sign? Because at 4, you do not equal 5. Between 4 and, let's see, 4 and 16, it's 0. Why is it 0? Because I just have a flat line. I just have a horizontal line right there, guys. And the derivative of that line, or the slope, is 0. So that means my derivative is 0. And for the next one, it's negative 5 halves. And that happens between 16 and 24. Okay? And I think that's it. So I think they're being kind of nice to us here. Nothing crazy there. All right, it says find the average rate of change of velocity. So this is really saying find the average acceleration over the time interval 8 to 20. Does the mean value theorem guarantee value c between 8 and 20 such that v prime of c is equal to the average rate of change? Why or why not? All right, first there's a lot of stuff going on. First, let's just find the average acceleration. All right, Average rate of change. So I'm going to write v of 20 minus v of 8 over 20 minus 8. Now, I know what some of you guys are saying. You're saying, Chavez, why aren't you doing the average formula? You just told me a little while ago that average speed was distance divided by time. Why aren't you doing it? Well, you actually are, guys. So average acceleration is equal to 1 over 20 minus 8 integral of acceleration. Now, remember, I'm going to put an 8 down here and a 20 up there. Well, antiderivative of acceleration is velocity. So all of this is just what I have written over here, guys. Look, v of 20 minus v of 8 over 20 minus 8. OMG, it's the same. So if you understand the concepts at hand, you're gonna be great. You're gonna be great. You're gonna do awesome. All right. Sorry, I got a little excited there. V of 20. So what's v of 20? V of 20 is, let's see. And don't depend just on this, guys. I would actually look at this slope here. Let's see. What was my slope again? Negative 5 over 2. So that means every time I go rise over run, so I go down 5, then right 2. So 16, 18, 20. So go down 10. So I'm at 20. If I go down 10, I'm at 10. So that's 10. So I'm going to write 10 minus v of 8. At 8, you are at 20. 20 over 20 minus 8. If I did a mistake, let me know, please. 10 minus 20 minus 8, that's 12. So negative 5 over 6. Let me make sure that I did everything right. V of 20, 10, V of 8, 20. Yeah, I don't see any mistakes there. All right, so that's my average acceleration. And then it says, let's see. Does the mean value theorem, guarantee value c between 8 and 20 such that v prime of c is equal to the average rate of change? Why or why not? Well, if you remember, the mean value theorem is this. And in order for the mean value theorem to work, you must be differentiable on the interval a to b and continuous on a to b. So the continuous part is good. But are you differentiable on a to b? Are you differentiable between 8 and 20? So if we look back, 8, you're right here, 20, you're right there. I guess I should probably be using. All right. So what I found is this. I found that average rate of change right there, which was negative 5, 6. Am I differentiable throughout the whole interval? No, you're not differentiable right there at 16. So the mean value theorem does not guarantee. So that's what I'm going to write. MVT does not guarantee a value C for A less than C less than 20 since V prime of 16 is not differentiable. I guess a better way to say that, I wouldn't say V prime. I would say since V is not differentiable at 16. Since V is not differentiable at t equals 16. I think that's perfect right there, guys. All right, I will do part 2 later on today, guys. I feel like that's enough for now. So I'll do part 2 in a little bit. So let's take a break, and I'll put a video in a little bit about part 2. All right, later, guys.